Okay, so boys and girls, we try another question for B. We still apply Newton law to solve the problem. So we are still going to follow the same step in order to apply our Newton's law to solve the problem. So we read through the question first. We have a 1500 load is held in equilibrium. See the keywords equilibriums. So perkataan equilibriums ni will telling you that you are going to apply Newton first law. Okay, summation force equal to 0 because the system is in equilibrium by 5 cables. So this load is held in equilibrium by 5 cable, 1, 2, 3, 4, 5. Okay, so we want to calculate the tension in the cable T1, T2, T3 and T4. So kita perlu buat kiraan. We want to determine the tension in the cable. So since we are going to determine the value of tension, so we need to apply Newton's first law. So to apply Newton's law, we are going to follow the problem solving strategy lah. So we have to identify all the forces that acting lah. So we need to draw free body diagram. So boys and girls, so if we refer to the system, so we will notice that we have two knots here. This is our first knot. Then this is the second knot. So if the system in equilibrium means that all the forces summation is equal to 0 lah. So I draw the free body diagram first step. So saya lukis dulu untuk knot 1 ni. So at the knot 1, there are 3 cable T3, T4 and weight. Along this cable is the weight 1500 Newton. So I have 3 forces horizontally. Here I have T4. Then here I have T3. So the angle is 80 degree. So this 80 degree will be equivalent to here lah. 80 degree. Okay. Then I have straight downward is the weight 1500 Newton. So this is the free body diagram for knot 1 dekat titik ni ya. Dekat tempat ni. Okay. And then we draw the free body diagram for the second knot here. Okay. Untuk ikatan kedua tu. So I'm going to have, this is the knot. So for that one, I'm going to have the T1. So the T1 is an angle 65. Perhatikan 65. So Z. So here will be 65 lah. Here will be 65 degree. Then horizontally, I have T2. Dan sengit macam ni dekat sini 80 degree I have T3. So this is the two free body diagram we have, and then before we apply the Newton's law, we have to choose our axis so that we can resolve all the forces into component X and component Y. So to make it easy, so I choose this one as component X. So here will be our component Y. So I will see that T4 is lie along component X. 1500 is lie along component Y. T3 can be resolved into component X and component Y. So I resolve T3. So I'll get component X will be T3 cos AD, and then the component Y will be T3 sin AD. Okay, so kita dah resolvekan T3 ni lah. Jadikan component X komponen Y. See, kita dah resolve dan letakkan semua forces tu kepada komponen dia. Same go for the second free body diagram lah. Same go for the second free body diagram. We put our axis. I put my axis. This is the Y. Okay. This is the X axis. So after I put my axis, I can see that T2 is lying along X axis. T1 ada angle 65, so T1 boleh resolve. Same go for T3, ada angle 80, so kita boleh resolve. So I resolve T1. So I'll get the component X for T1 will be T1 cos 65. And then the component Y for T1 will be T1 sin 65. Opposite, component ni opposite to the angle, so sin. Component ni adjacent to the angle, so is cos. Okay, so kita dah resolvekan dia. So saya buang yang ni, kita dah resolvekan. Dia jadi dua komponen. And then same go for T3 lah. So T3 pun kita resolve. So I resolve my T3. So I'll have the component X will be T3 cos 80. And then the component Y will be T3 sin 80. Okay. So the result. Okay. So T3 ni kita dah pecahkan dia. Okay. Kita dah pecahkan dia. Resolvekan dia kepada komponen X dia dan juga komponen Y dia. Okay, so we have done with our resolving. Then what we want to do, we are going to apply our Newton's law. So we are going to apply our Newton's law. So we are going to apply our Newton's law. So according to the keywords, we are going to apply Newton's first law. So class, after we have resolved all the forces, so we are going to apply the Newton's law of motion. So since the question said the system is held in equilibrium, so we know that equilibrium means the forces is balanced, so we are going to apply Newton's first law. So which one we want to start first? So ikut pengalaman kita, mestilah bermula dengan tempat yang kita ada, nilai yang kita tahulah. So kita mula dekat tempat ni. So this one I highlight. So we are going to start with our component Y. This component Y. So which component is lying along this y-axis? T3 sin 80 pointing upward, 1500 Newton pointing downward. So we apply Newton's first law to our component Y. So total force component Y equal to 0. So we have T3 sin 80 minus because 1500 is pointing downward, so equal to 0. So rearrange, we can find our T3 loh. 1500 pindah sini jadi positif, divide by sin 80. So tekan calculator, you will get is around 1523.14 Newton. Yes, we have solved for the first question. Our T3 is this value. Okay, then we already get our T3. So T3 sudah dapat. Jadi kalau nilai T3 anda sudah dapat, you dah dapat nilai T3, then you boleh cari T4 lah. Gunakan komponen X. Okay, so kita guna komponen X pula. Teacher highlight kan supaya nampak. So fokus kepada komponen X. This is komponen X. So, system is in equilibrium. So, the component X, the summation of force, component X also equal to 0. So, T4 is rightward positive, T3 is leftward negative. So, we have T4 minus T3 cos AT equal to 0. So, your T4 will be T3 cos AT. T3 cos AT, and then we already know the value of T3, so 1523.14 cos AT. So I'll get my T4 is 264.49 Newton. Yes, we done with our T4. Okay, so we get our value of T4. Now we are going to solve T1 and T2. So, perhatikan. Okay, so in order to solve T1 and T2, kita akan gunakan free body diagram yang kedua lah. So, T3 kita dah dapat. So, kita boleh selesaikan untuk dapatkan T1 dan T2 lah. So, mungkin saya mula dengan komponen Y dululah. Komponen Y kita. So, perhatikan komponen Y, sepanjang komponen Y, kita ada dua forces, T1 sin 65 dan T3 sin 80. So, we apply Newton first law, komponen Y equal to 0. So, T1 sin 65 minus, why minus? Because T3 sin 80 is pointing downward. T3 sin 80 equal to 0. So, T1 sin 65 will equal to T3 sin 80. So, kita boleh cari T1 lah. So, T1 akan sama dengan T3 sin 80 bahagi sin 65. Then, kita gantikan nilai. So, T3 kita tadi 1523.14 sin 80 bahagi sin 65. Okay, tekan calculator, you akan dapat T1 you 1655.07 Newton. Okay, then we get our value for T1. So, after we solve T1, we can use the component X, our component X, then we can find our T2. So, untuk komponen X ni, T3 cos 80 dan T2 adalah positif sebab dia point to the right, but T1 cos 65 point to the left, so it's negative. So, kita ada summation force komponen X equal to 0. So, Cici kecilkan supaya nampak forces dia. So, we have, kita ada yang ni dan ni. Okay, so kita ada T3 cos 80 plus T2. Dua-dua ni positif sebab dua-dua ni hala ke sebelah kanan. And then, T1 cos 65 tu negatif lah sebab dia pergi ke sebelah kiri. So, minus T1 cos 65 equal to 0. Okay, dan kita boleh masukkan nilai. T3 adalah 1523.14 cos 80 plus T2 minus T1 nilai ni 1655.07 cos 65 equal to 0. Nampak? So, kita boleh cari T2. So, kita boleh cari T2. So, calculate with calculator, you get T2 is around 434.97 Newton. So, we get our answer for T2. So, we done with the solution. So, basically, kalau you perhatikan, teacher sentiasa follow the step. I'll draw my free body diagram dulu, then I'll choose the axis, Now I'm going to resolve the forces into component and then baru saya apply Newton's law to solve the question. How I know which law I want to apply? Saya nak apply first law of motion ke second law? Saya tengok keywords dalam soalan. So soalan ni mengikut keywords dia equilibrium. So equilibrium means the force is balanced. So saya akan apply Newton first law. Summation force equal to 0. Okay, boleh? So you might try to apply Newton first law ni, ikut step ni. You can try question 5, 6. Yeah, this one I'm going to apply Newton first law. So cuba selesaikan 5 dengan 6 mengikut step ni lah. Okay, ikut problem solving strategy step ni.